In this video, we're going to look at the relationship between surface area and friction, and then use the children's understanding of that to look at air resistance, because there's a lovely link there. And for this investigation, we're going to again make use of the slide pull, which you looked at in the last video. So in the last video, we had the slide and it was being pulled this way. And we can simply say to the children, we can ask the children, what's the surface area? How much of the slide is in contact with the surface that is being dragged across? Now, if you want to just do it quick and easy, you can just say how many blocks are touching. Now this way you can see we've got 3 rows of 4, so you can see, well, there's 12 blocks that are touching. That's the surface area of this one. The challenge for the question for the children then is, well, what happens if you turn it from being dragged this way, like this, to this way? What's the surface area now? Well, it's only 4. There's only 4 blocks touching. Okay? There was 12 last time, and now there's only 4. What difference will that have for the friction for the slide pull? How many bricks do you think it will need to be pulled when we've got a smaller surface area? You can leave the children with that question. Let them consider it and talk about it. Let them think through their reasons. You can remind them of things from Newton's first law. We know that a body is going to stay in motion unless it's acted upon by another force. We know that force is friction. And what we've learned about friction is friction depends on a few different things. It depends on the 2 surfaces rubbing against each other. They did that in the last investigation, where they looked at the different properties of the different surfaces and what effect that made. There's an effect about the weight of when the 2 surfaces are pressed against one another. That can affect friction. We know that just by pushing it down with our hand and rubbing it can be harder to move. And then the other part is the amount of surfaces that are touching against each other, or the surface area. So if we've got a big surface being pulled or a small surface being pulled, that's what we're going to be looking at now. So the children can make their predictions and see what's going to happen. And then in the exact same way as before, they're going to add their bricks to the bags and see what happens. Now there can be lots of interesting discussion that comes in here. Okay, hopefully what we're going to see is that you need fewer bricks to pull the slide when it's got a smaller surface area. But I'm going to be honest with you, that's not going to happen every time. But that's a great learning moment for the children, because in science and engineering, people don't test things once. The scientists who are making new medicine for us, they don't just check that it's safe once, they check it lots of times. The engineers that are building things for us, they don't just check it once, they check it lots of times. And you can have a conversation with the children about how often would you want to check something? How often would you want to check a bridge? How often would you want to check some medicine? Okay, so how many times would you want to check this? Are you just going to do it once, or are you going to do it 5 times? And if you do it more than once, you then got a fantastic opportunity to investigate some maths looking at averages. So you can say, well, we've got this many, 5 different results. Here's the range, here's the mode, here's the median, here's the mean. There's lots of great maths in there for the children. So it's a great way to take that forward. So that's a lovely way to begin investigating the effect of surface area on friction. Now, another very visual way that you can do this with your children is by using some books to demonstrate the effect of surface area. Now, if I put these 2 books on top of one another and just gently push them, you can see that there's not much surface area. It's pretty easy for me to push these 2 books off one another, okay? If I fold them, so there's just 1 page inside 1 page, it's pretty easy for me to pull them apart. There's not much friction, there's not much resistance for me doing that. However, if I was to sit and fold in all the different pages, and this is something that you could either ask people to do if they're needing an extra job, or you could have done previously, just sitting like this, and then try and find it apart, you'll find it's much, much harder. In fact, I would challenge that none of your children will be able to do it. And the question you can ask the kids is, why is that? Why is it so much harder? The reason is, every time you fold these different pages on top of each other, you're increasing the surface area. So instead of just 2 pages being in contact, you'll have 50 pages in contact, or 7 pages in contact, or however many you folded over. So even now, we don't need to sit and watch me do all of these. Even now, I've increased the number of pages in contact. So if I try and pull this apart, you can see it's a lot harder. If you were to take the time and to do the whole book, it would be impossible to pull apart. So that's another little way that you can show children, demonstrate to children the effect of surface area on increasing friction. Now, here's how this links to air resistance. In the link below, you'll find templates for sheets like this, where we've got the outlines of cones. Now what we're going to do is cut these cones out around the edge, and then we're going to cut in along these lines here. It's important to say we're not going to cut this bit out. That's just where we're going to fold. Now the reason we're not going to cut it out is because later on in the experiment, if we cut it out, children will think the results we get are because the cones are lighter, because we've gotten rid of different amounts of paper, okay? So we don't get rid of anything inside the circle. But what I'm going to do now is I'm going to cut those out, and I'll come back and I'll show you. Okay, so here you can see I've cut out 2 cones, and I'm going to explain a bit more about what I meant there. So you can see we've got the lines in the middle. So what we're going to do is we're going to just cut in on one of the lines to the centre, and then we're just going to fold round to the other line, and that makes us a cone. Now with this extra bit, we're not going to cut that off, we're just going to fold it in. Now what the children can either do is glue or sellotape that down. Now what that will give us is lots of different cones with different surface areas. If we're only cutting a little bit out, like this, we'd have a very broad, a very large surface area, a very flat cone. If we've got a big area that we're pulling in like this one, then we're going to have a much taller cone with a smaller surface area. But it's important that we don't cut this extra bit out, because if we throw it away, the children will think the results of the experiment are due to it being lighter. So I'm going to go ahead and finish making those cones, and then I'll show you the experiment. Okay, so I've made 2 of the cones now. There's 4 in the pack. So there's 4 different cones the children can investigate. And you can see that I've got a very flat cone, and I've got a much more pointy cone. Now the investigation the children are going to do is first predict which will hit the ground first when they're dropped from a height, and then why. Now the learning here is about the surface area of the cones. The cone with the greatest surface area will produce more air resistance and will fall slower than the cone with the steeper point and the slower surface area. Now there's another concept cartoon that you can use. You'll find it in the links below the video, and you can ask the children to do their thinking on that concept cartoon before and after the experiment, and that's just another way that you can check in on their learning and check in on their thinking. Now, you need to have a discussion with the children about how you can make this a fair test. It's not going to be fair if the children hold the cones like this or drop them at different times. So there needs to be a way that they can have a fair test, and the children can investigate that. So whether it's lining up their hands with a desk or a windowsill or a meter stick or something, and then having a 3, 2, 1 countdown so they can drop. But what you'll see is as I drop these, one falls much quicker than the other, and the reason that is because this has a larger surface area, so it produces more air resistance. So you can see the link between our sled drag, the page pull, and these cones. It's a lovely way to develop that concept for the children.